Welcome to Raw Machines, a journey to discover the most impressive processes around the world. Today we will follow the rebirth journey of wood, from the forests of Oregon and Montana to modern mills in the US and Europe, where sawn lumber and plywood are born. This is not just a story of harvesting and processing, but a symphony between nature, machinery, and human ingenuity. Let's start right now. The sunrise in Oregon is not noisy. Every tree in this forest has stood here for over half a century. Its roots deep in the earth, its canopy touching the clouds. But today, some of them have reached the end of their life cycle, ready to become part of new constructions. As the harvester machine moves in, the forest's stillness vanishes. The hydraulic cutting head extends, embracing the trunk, the circular saw blade spinning rapidly. In just a few seconds, a 40-meter pine tree is felled, its trunk precisely cut into segments. Inside the cabin, the operator holds the joystick like playing a video game, but every maneuver is the result of years of experience. One cutting beat, one twist of the wrist, the giant tree falls as softly as a blade of grass. They call it the dance of steel and wood. After the trees are brought to the staging area, a log loader appears. It lifts each log like giant pencils, neatly stacking them onto specialized trucks. The logs are placed with perfect calculation. Center of gravity, orientation, stacking height, all to ensure safety as the trucks navigate the winding mountain roads. Truck driver sets off. Each trip carries about 25 tons of wood, traversing winding roads through the valleys. On both sides of the road, young trees have already started to grow, a testament to the continuously regenerating life cycle of the forest. Log truck drivers often compare their job to the bloodline of the forestry industry. They don't just transport wood, but the labor value of the entire logging crew. Each trip is calculated based on time, volume, and route to ensure the wood reaches the mill in sync with the production schedule. From here, the log trucks head to the town of Cottage Grove, where the WEYERHAEUSER processing plant operates with near absolute precision. There, these logs will be scanned by lasers, measured down to the millimeter, and cut into perfect boards. WEYERHAEUSER was founded in 1900 by Frederick Weyerhauser. Having undergone many generations of improvements, it is now one of the most modern wood processing facilities in the United States. The main raw material here is Douglas fir, a type of wood Americans regard as a symbol of strength and resilience. Right from the entrance, trucks fully loaded with timber from the forest are directed to the first area, the log deck, a gigantic wood yard where every log is identified. The logs are sorted according to size, species, and quality grade. A laser scanning system sweeps across each log, calculating its diameter, curvature, and even identifying internal defects. All data is instantly transmitted to the central computer, where artificial intelligence software simulates the optimal cutting path to maximize the utilization of every single log. Next, the log is fed into the debarker. Inside, steel teeth collide with the bark, stripping off each layer cleanly. The bark is collected separately, ground up for organic fertilizer, or burned in a biomass boiler, generating energy for the mill itself. No part of the log goes to waste. Even the rough exterior is utilized. From here, the wood is transferred to the main sawing area. The buck saw performs the first task, cutting the round logs into the pre-calculated target lengths. Following this, the Ramey kicker system automatically sorts the logs based on their small end diameter and pushes them onto the appropriate deck. At this point, the Ramey operator plays a fine-tuning role, using grapples to remove any broken logs and aligning and holding the logs in straight position. The sawing stage is the heart of the mill. The 3D scanning system determines the optimal cutting direction, and the log turner rotates the log into the correct position, allowing the feed rollers to stabilize it before cutting. Next, the wood is transferred to the cant creation area. The side chip heads cut the first two faces flat, while the profiler chip heads finish the remaining two faces, forming a squared log called a cant. This cant is then fed into the gang saw. Here, dozens of saw blades operate simultaneously, cutting the wood block into multiple parallel boards all at once. The speed is high, but everything is monitored by sensors. If small vibrations or deviations are detected, the system automatically adjusts immediately to prevent waste. The rough boards continue through the edger, where they are edged, removing the curved exterior portion, called weighing, to create flat, neat boards. Following that is the trimmer saw, where the boards are cut to standard lengths, 8, 10, 12, or 16 feet. Sensors automatically detect cracks or dead knots, then calculate the optimal cutting points to minimize waste. When the boards are fully cut, they enter the sorting and grading stage. Dozens of high-speed cameras and moisture sensors scan every board, assessing it according to quality grade. Robotic arms push each board to its corresponding area, classifying it as grade A, B, or C. Although the process is almost fully automated, the human eye remains present. Manual inspectors randomly check high-grade lots to ensure absolutely perfect standards. When full, the bins automatically open for the boards to drop onto a series of sorting decks, then move to the stacker machine. Here, the stacker arranges the boards into uniform bundles, slightly offset to reduce the need for wooden stickers. Finally, forklifts move the bundles out to the GIP yard, where they are stored before finishing. From the GIP yard, the bundles of rough lumber are transported by forklift to the planer mill, the area that transforms rough wood into the finished product. The planer operates at an impressive speed, capable of reaching 2,400 feet per minute. Blades spin at extremely high speeds, smoothing the board surfaces and creating sharp, clean cuts that look almost polished. After planing, the Lucidine scanner checks the quality of each board. The boards are sprayed with protective chemicals, measured for curvature in the warp tunnel, and then sent to the grading table to mark defects. Next, the grade reader machine verifies the quality class of the board. If necessary, the planer trimmer will cut the ends shorter to increase usable value. The offcuts are recovered by the recycler and fed back into the line. Every standard compliant board is stamped with its grade mark. Once the green light confirms the quality, they are transferred to the planer bins, and then to the finished product stacker. In the final stage, the lumber packages are pressed squarely, tightly strapped, and sprayed with a protective coating. Robots handle the barcode application, while employees attach identification tags before forklifts move the finished bundles out to the finished goods yard. The FIFO, first in, first out principle is strictly adhered to, ensuring inventory is logically and efficiently rotated. When it's time for delivery, rail cars are fully loaded and secured carefully, and trucks are ready to depart, carrying the finished lumber packages to every region, from construction sites to distributors nationwide. Each log, from its time deep in the forest to becoming a finished product, has gone through dozens of steps. Every step in this journey is a harmonious combination of automation and the human touch, between speed and precision. The entire production line is a living testament to how humans harness the power of machinery, not to replace, but to elevate their craftsmanship, transforming the raw timber of nature into refined building materials for a new world. From Cottage Grove, the wood's journey continues to another processing mill, Veneer Inc. This facility doesn't produce traditional sawn lumber, but rather a different type of material, engineered plywood, a material that has transformed the entire modern construction industry. At this mill, the journey of a plywood sheet begins with 8-foot logs. They are carefully selected, mostly pine or Douglas fir, two species known for fine, uniform grain, ease of peeling, and high strength when layered. After being debarked and cleaned, the logs are fed into the veneer lathe. This machine operates like a giant pencil sharpener. The log is clamped tightly at both ends and rotated at high speed, while a long knife blade presses against its surface. With each rotation, the blade cuts off a thin layer of wood, which curls into a long, continuous ribbon. Operators monitor the process, adjusting the cutting force so the veneer is uniform and the fibers do not tear. When the log is peeled down to a small core, it is removed and transferred for recycling or used as biomass fuel. The continuous veneer ribbon is then cut into sheets by the clipper machine. Here, defects such as large knots, cracks, or voids are removed. Smooth, flawless sheets will become the face layers of the plywood, while sheets with minor defects are used for the inner core layers. An automatic camera system captures images of each sheet, grading them in an instant. Every piece of wood is assigned its predetermined role in the structure of the finished panel. Next is veneer drying. This is a delicate and crucial stage. The veneer is fed into a multi-deck dryer, or multi-stage kiln, where the hot air is controlled to the precise degree, reducing the moisture content from 70% down to 8%. If the process is too fast, the veneer will crack. If too slow, productivity decreases. The margin between speed and quality is thin, and Veneer has learned to walk that line with absolute precision. Finally, these units are sent to the strapping machine, bound tightly, and stored inside the warehouse to remain dry. The veneer leaves Rayonier and finds its way to plywood manufacturing plants. Rayonier's customers will use them, depending on the final product they want to create. For instance, it might be used as high-grade underlayment for flooring or as sheathing for structural projects. It's fascinating. I recently saw someone building a new house nearby. Instead of using common OSB, oriented strand board, they opted for sheathing made from Rayonier veneer, and I am genuinely impressed with that choice. Now we leave the brightly lit mechanical lines and return to where it all began, the forest. But this time it is in a different region of the United States, Montana, a wild land of mountains and old-growth pines, where Plum Creek writes the next chapter of the story of forest regeneration and sustainable wood. Plum Creek owns and manages hundreds of thousands of hectares of natural forest in northwestern Montana. The forest here is not single species, but a mix of lodgepole pine, larch, spruce, and Douglas fir. Each species has unique properties, yielding wood with different structures, colors, and durability. Thanks to this diversity, the company can maintain production year-round without relying on a single source. In their processing facilities, Plum Creek produces various materials, but is particularly renowned for its engineered plywood. Similar to Rayonier's product, but with its own unique structure and process suited to the characteristics of cold region timber. So, let's see right now what the processing workflow for this type of product looks like. Everything begins in the debarking and steaming area. This is where the logs are soaked in hot water at 170 degrees for 12 hours. A process that softens every wood fiber, allowing the layers to separate as smoothly as silk when fed into the lathe. When the log is sufficiently softened, it is fed into the veneer lathe. The blade rotates opposite to the log's axis, precisely positioned by lasers down to the micrometer. Each rotation cuts a thin ribbon of wood, wrapping around the spindle before falling onto the conveyor. Everything happens in a synchronized mechanical rhythm. The veneer ribbon then proceeds into the clipper to slice the ribbon and cut out defects. Full-size sheets are used for the face, back, or core layers and are sent to the stacker. Smaller pieces are routed to the green chain for sorting. Anything damaged or less than 8 inches wide is chipped and sent to the MDF mill, medium density fiberboard. After cutting, they are fed into a multi-zone drying system. In each zone, the heat is adjusted according to the thickness and wood species. A deviation of just a few degrees could warp or crack the entire veneer batch. Next is the repair and recovery stage. Instead of discarding defective veneer, the robotic plug line inserts small wooden plugs into knot holes or defects, matching the color and grains so perfectly that they are nearly invisible. The remaining scraps are assembled using a composer machine, reconstituting them into new veneer core material. Here, the wood is utilized to the point where there is almost zero waste. Once the veneer is ready, the sheets are layered and glued on the layup line. Each layer is placed with the grain running perpendicular to the previous one, the golden rule for plywood's superior strength. They are then hot pressed at 205 degrees for 5 minutes, under hundreds of psi of pressure. Under the high heat, the adhesive cures, bonding the veneer layers into a unified block. Now we have the plywood panels, but they still need to go through one more step to repair defects and increase the product value. Small defects are filled with putty. Larger defects are addressed on the poly line, where these men use a router and epoxy poly resin sticks to patch holes and cracks. They are then trimmed and sanded to create a smooth surface before being graded one final time and stacked for shipment. What sets Plum Creek apart is not just the product, but the operating philosophy. The company strictly adheres to international standards for biological conservation. For Plum Creek, harvesting is not taking away, but managing the forest life cycle. Mature trees are harvested, young trees continue to grow, and that cycle repeats, uninterrupted. In this model, the forest becomes a truly renewable energy source, an ecological asset rather than just a raw material for production. It is an unspoken covenant between humanity and the forest. We take, but we also give back. Plum Creek does not just produce material, they nurture the future of wood, the future of sustainability. On the other side of the Atlantic Ocean, in the lush green plains of Belarus, the journey of wood continues. Here, the Lumber LLC mill operates a specialized production line, where lumber is transformed into standardized EPAL European pallets, an item that seems simple, but is the foundation for the entire global goods shipping chain. The raw materials for pallets are meticulously selected, primarily pine and spruce wood, two types known for their light weight, high mechanical strength, and good compressive resistance. Before being put into production, they are dried until the moisture content is less than 20%. Dry wood ensures the pallets won't warp or mold and can maintain stable load-bearing capacity under changing climatic conditions, especially since they are used everywhere, from Europe to Asia. In the main workshop, the CNC automated cutting line operates non-stop. The rough wood blocks pass through high-speed rotary saw blades, being cut into individual pieces according to standard dimensions. Deck boards, top and bottom planks, and square blocks for the pallet feet. Computers control the entire process, ensuring the tolerance is only a few millimeters. Each batch of wood is coded, recording information about its origin and production lot. This is a mandatory requirement under European standards. Once cut, the lumber moves to the automated assembly line. Dozens of pneumatic nailers operate simultaneously, creating a rhythmic sound like electronic drums. Special spiral nails, designed to grip over 40% tighter than standard nails, fasten all the wood pieces into a cohesive unit. The machine knows precisely where 2 nails are needed, where 3 are required, the exact depth, and the angle. Every finished pallet is absolutely identical, with near zero tolerance for error. Once assembled, the pallets move into the drying and stamping chamber. This is a mandatory standard of the European Union. All export pallets must be re-dried to eliminate insects and meet the ISPM 15 standard. Temperature, time, and humidity are automatically recorded for each batch, serving as the pallet's biological passport. When the pallet meets the standard, a heated metal iron descends, stamping the EPAL mark onto the wood surface. A slight sizzle rings out as the metal touches the wood, leaving a square stamp, the symbol of uniformity, safety, and legal protection across Europe. In the finishing area, the edges of the wood are slightly chamfered, beveled, to prevent splintering, allowing forklifts easy access without damaging the pallet. A routing machine runs along the edges, smoothing the surface, which both increases user safety and extends the product's lifespan. Afterward, the pallets are stacked and bundled using steel strapping. The automatic lifting system can stack 20 pieces into one bundle, neatly arranged like giant Lego blocks. From here, they will leave Belarus, perhaps heading to an electronics factory in Germany, a container port in the Netherlands, or a warehouse in Poland, where they will continue to serve the global shipping cycle. What is particularly noteworthy is the sustainable cycle of this system. Wooden pallets are not just produced and then discarded. They are reused, repaired, and recycled multiple times. When old pallets break, the salvageable wooden sections are reclaimed, sanded, and reassembled. Pallets that can no longer be used are ground into wood chips, which are made into biomass pellets or organic fertilizer. This continuous cycle turns wood, a seemingly finite material, into a continuously renewable resource. For producers like Lumber LLC, every pallet is not just a product, but a commitment. No waste, continuous rebirth. In the modern industrial world, that is the simplest and most powerful way for humanity to continue living with the forest rather than living off its loss. From the Oregon forests to modern mills, from Veneer's Plywood Factory to the Pallet line in Belarus, the journey of wood has traversed many spaces, technologies, and philosophies. But no matter where it is or in what form, the essence of the timber industry remains unchanged. It is the combination of the human touch, technical ingenuity, and the cycle of nature. Looking back at the entire journey, a clear message emerges. Humanity does not stand outside of nature, but is a part of its rhythm. Harvesting does not equate to destruction, if it is accompanied by regeneration. Cutting, sawing, and processing do not diminish the value of the forest. If we know how to transform each log into multiple new lives, from house roofs, wooden walls, to shipping pallets, and that journey will continue as long as there are green forests, as long as there are workers who understand the value of every log, and as long as there are hands that know how to turn wood into the future. Thank you for listening to the end of the story. If you also enjoy similar videos, please hit the like button, share, and subscribe to the channel so you don't miss any fascinating stories to come. Raw Machines says goodbye and see you next time.